Two, one. Good afternoon, everybody. Very excited indeed to be joined by Robert from Lloyds Banking Group, who is going to give you a quick run through of Python 101. So yeah, I'll pass over to you, Robert. Thank you very much.
Thanks, Alex. Happy to be here. Hi, everyone. I'm Robert Callender, a software engineer at Lloyds Banking Group, where I specialize in Python. I joined Lloyds in 2019, where I work in data science. And yeah, that word Python, you've probably heard it bandied a lot in programming, but you might be wondering, well, what is it? Well, today we're going to cover that. We're going to talk about the history of Python, how it's different to other languages, how it's used by businesses, and then we're going to talk about some key fundamentals of Python, like data types, collections, and loops, finally bringing them together into one big Python function at the end. Now, what is Python? Well, Python is what's called a general purpose programming language, meaning anything you want to do in software development, whether it's creating a database, making a web page, or even just running a function, can be done with Python. And it's similar to other languages like Java or C++ in this respect. However, there's two key benefits which Python has, which these other languages don't. Firstly, it's ease of use. Python is very easy to write. It's concise. You can tell how the code is meant to flow by the ordering of it. And it has very few keywords. Also, a kind of unforeseen benefit of this is it means Python is very easy to read, and also people can often tell very easily whether someone's writing good Python or not. It's also when it was created by its creator Guido van Rossum in the late 80s, early 90s, it was created from the start as what's called an open source language, meaning anyone can look at the source code. And so there's millions of people working on it and a huge number of Python packages out there. Over 300 plus are just built into Python alone. This means that often when you're dealing with a particularly not a tricky problem in Python, a coding problem, usually you can just import a package from the Python hub to solve your problem. You don't have to figure out some nitty-gritty difficult code from scratch by yourself. Being open source from the beginning also makes Python quite a sort of trailblazer as a language, because these other languages here like Java and C#, they also became open source languages, but both only over a decade after they were created. So in some ways, Python has been a real trailblazer, and also this open source nature and ease of use means that Python is a very easy language to scale with. Now here's the creator. Here's Guido himself here. And the reason he actually called it Python was because Monty Python was one of his favorite shows at the time. Now, he released what was called the incubator or initial version of Python in 1991. This was just very basic. It had a few data types. You could do you could work with classes and do some object-oriented programming with it. But that was it really. Fast forward 17 years later to 2008, when Python 3, or as I call it, modern Python, is released. This has a lot more features. It has support for complex numbers, even has a few keyword arguments, and it's got a lot more. It's got a lot more data types. Now, note there, I call it modern Python. So the support for the previous version of Python, Python 2, that was decommissioned in 2020. So nowadays, if you want to download Python and start coding with it, you need to make sure you've downloaded Python 3. But you might still probably are wondering, so how did Python become so popular? Well, the key turning point came 4 years later in 2012, when at the time, a lot of data scientists were doing their statistical analysis using R. Now, R is a really good language for doing this, and it's very easy to write, but it's not a general purpose programming language. You can't say, take some data, manipulate it, and then just stick it in a web page like you can with Python, because Python's a general purpose programming language. This also meant that Python increasingly replaced R and became popular with data scientists and people more generally who are involved in machine learning and artificial intelligence. And then even more generally, just with people who were getting started in coding, it became popular with them because of Python's ease of use. Now, it's not just people and developers that Python is popular with. It's also popular with a lot of big businesses here. So we've got JP Morgan, Amazon, IBM, Mozilla. So it's a very popular language out there. And there's two main ways really in which Python is used. It's either used for machine learning, like with Netflix, Zopa, and Monzo there, or it's used as a core platform language. So for things like Reddit, Instagram, they're built in Python. And the main example I'd like to draw your attention to here, which is YouTube. Now, 720,000 hours of video uploaded per day on YouTube. That's a huge amount, and YouTube wouldn't be able to handle all that traffic if it wasn't for Python. So to give you a bit of context, back in 2005, when Google bought YouTube, they realized that, and the explosive growth that YouTube was experiencing, they realized that YouTube, as it was, wouldn't be able to handle it. At that time, YouTube was actually coded in PHP, but they realized there'd be a lot of limitations and restrictions in continuing to use PHP. So they, cast around for a different language to code YouTube in, and they settled on Python. Again, because of its open source nature, there are already a lot of Python packages out there that could handle traffic efficiently, that could deal with security, and so Google settled on Python. An unforeseen benefit of Python as well was that it was also, and so this made Python very, it was very quick, very easy for Google to change YouTube into being coded in Python rather than PHP because of its open source nature. It also meant that an unforeseen benefit was YouTube, its interface became much better as a result of being coded in Python. So without Python, YouTube would not be the massive phenomenon it is today. Now, I've talked a lot about how about how Python is very easy to use and easy to write, but I'm going to show you this in an example here. The sort of classic hello world printing example in programming. First, I'm going to show you how to do that in Java, then with Python, and you can make your mind up as to which looks easier to you. So for that, I'm going to go on some online compilers. Now you can find if you don't want to go into like downloading Python and you just want to go to a place on the internet where you can just run some code with minimal fuss, then that's what online compilers are for. You don't have to download anything. You can just put a link in and go to one. You can choose different ones to the ones I've used if you want, but either way, it doesn't matter. So if we just do this example here, so get rid of those lines, type in hello world here, and get rid of this, and execute. There we go, it's printed hello world. But as you can see, there's quite a lot of stuff going on here, and I wasn't even doing this from scratch. There's a lot of keywords, a lot of curly braces to remember. There's semicolon there to be aware of as well. And it's just 5 lines of code all to just print 2 words. Now, on the other hand, if we try and do that in Python, this is all you need. 1 line right there. Didn't even need to worry about semicolons. So I think it's pretty clear to see that particularly for someone who's new to programming, this is much more intimidating and complicated than this. That's a pretty good example of how easy it is to write Python. Now let's actually get into some sort of fundamentals of Python. So here we've got a few of the main data types in Python, strings, which are indicated by the type str, and a string is basically a combination of letters of the alphabet, digits, and any symbol you can create by pressing a button on a keyboard, basically. So that's why I've got this keyboard image here to keep that in your mind. Another thing to bear in mind with strings is that you can tell if something's a string in Python because it will be enclosed in double or single quotes. Then we've got integers denoted by the type int. That just basically means whole numbers, so things like -5, 3, and 0. Then there's floats denoted by the type float. Now you might be wondering what on earth is a float, but that just means a decimal number, so things like 7.86 minus 9.3, 10.356. Complex numbers denoted by the type complex. So if you remember back to maths at school, that was certainly a little while back for me, but if you remember back to maths at school, I is used to mean the square root of -1, and a complex number has 2 parts. It's got a real part, which is a number without an I next to it, and then it's got an imaginary part, which is a number with an I next to it. And finally, you've got booleans denoted by the type bool. So that just means true or false values, essentially. But a key thing to note with Python, unlike a lot of other languages, is that when you write true or false, they have to start with a capital T or F, respectively. Now, let's show you those data types. So as you can see, hello world there, it's enclosed in double quotes, and it's a combination of the letters HELOWRD, and it's also using the special characters space and exclamation mark. So yeah, so that should be a string, but now I'm going to actually prove that to you. So we've got this type function here. Now the type function just does what it says on the tin. Whatever variable, value, or constant you feed into it, it'll just tell you the data type of the input essentially. And then you've got the print function, which takes the input and displays it to this output terminal at the bottom here. So for hello world, this should display str at the bottom here because it's a string. There we go, str. So hello world's a string. Then let's look at ints. So 8 is a whole number. That's an example of an int. So it should show int at the bottom here, and it does. Like that. Floats. So 9.67. That's going to show float at the bottom. There we go again. And now we're going to do a complex number, so 3 plus 4j. Now, this is an interesting quirk of Python to note. Note that I said before, the imaginary part in a complex number should have an I in it, but in Python they have a j instead. So that's something to watch out for. Now, if I print that at the bottom here, that's going to say complex, and it does. Just to prove that, by the way, you shouldn't write I here. The right eye here, you'll see it's turned from blue to white, meaning we're going to get an error at the bottom here. And we do. So you get this invalid syntax error. So when you're doing complex numbers in Python, make sure to put J's rather than I's. Another quirk of Python when it comes to complex numbers is that it doesn't recognize the idea of an imaginary number type. So in maths at school, this would be 4i in maths at school, but this would be considered an imaginary number rather than a complex number. But in Python, it draws no such distinction. Even though the real part is 0 here, it's still going to consider this of data type complex. And it does. And finally, we're going to look at Boolean values, bools, and this is true here. Note that, again, I've started it with a capital T. That's going to show bool at the bottom there. And it does. So that's some of the main data types in Python. But those are sort of really single value data types. What happens when you want to group them together? Well, for that, we have something called collections in Python. And there's four main collections. There's lists, tuples, sets, and dictionaries. Now, lists are indicated by having square brackets in them, and they're ordered, meaning they have a structure in terms of when the elements are added. They are mutable in terms of meaning you can change that structure after the list's been initialized. The elements can change their values, and they allow duplicates. So lists are what I like to call the workhorse collection of Python, or the most flexible, because you're allowed to do so many things with them, basically. Then you've got tuples. Now, tuples are a little more restrictive than lists. Tuples are indicated with just normal brackets, and unlike lists, they're immutable, so you can't change their structure once they've been initialized. Then there's sets, indicated with curly brackets, and the main difference with sets is that they don't allow duplicates, unlike tuples and lists. And finally, dictionaries. Now, dictionaries are kind of the odd one out compared to the other collections. Like sets, they're indicated with curly brackets, but rather than having sort of single data type elements in them, like strings, integers, complex numbers, whatever, dictionaries have what's called key value pairs. Meaning, so what is a key value pair? Well, it's made up of a key, which has to be a string. Then you have a colon, and then you have the value. And the value can be of any data type. That can be another string, or it can be an integer or a complex number, whatever you want it to be. Now, again, let's show you that in the compiler. So we're going to start with lists because, as I say, they're the most flexible. They're the easiest to use. And we're just going to start with a list of fruits here. So we've got apple, banana, cherry, and I'm just going to print it out. Now, as I said before, lists, they're ordered. So when we print out the list here, we're always going to see apple, banana, cherry in that order. That's never going to change. So if I print that list out to the output terminal and run the code, yeah, it says apple, banana, cherry. Do it again, still apple, banana, cherry. Do it again, still apple, banana, cherry. Okay, so lists, they are ordered. As I said before, lists are also mutable. So say we wanted to add the element or the string orange at the end of the list, we can do that. Now note I've put this 3 here, and you might be wondering what that means. So 3 is an example of what's called an index in a list, and that relates back to lists having this kind of order, being ordered, having this structure. So apple here being the first element that's added to the list, that has an index of 0. Banana being the second element added to the list has an index of 1. Cherry being the third element added to the list has an index of 2. And as such, since we're trying to add orange at the end and it'll be the fourth element, it'll have an index of 3. Now it might seem a bit odd there that even though apple is the first element, it has an index of 0 rather than 1. And this is something you've got to bear in mind with Python. Python is what's called a indexing from 0 or 0 indexing language as a result of this. So bear that in mind when dealing with collections, particularly lists in Python. So if I run this now, it should say apple, banana, cherry, orange at the bottom. And it does. So lists, they are mutable. You can also change the value of an element in a list after it's been initialized. So say I wanted to take the first element there, apple, and so note I've got this square bracket and this 0 here, and that's telling Python that I want to look at the first element in my list, which is apple in this case. So if we want to change the value from apple to strawberry, we can do that with a list. And so this is going to say strawberry, banana, cherry at the bottom here. That's strawberry, banana, cherry. So lists, you can change the value of an element in a list after it's been initialized. And finally, duplicates. So like I said before, lists, more than happy to have duplicates. That's not a problem. So if I type banana, banana, cherry twice here, that's going to print banana, banana, cherry at the bottom without any problems. There you go. You can see banana twice here. Banana, banana, cherry. Okay, now moving on to, and as I said before, lists indicated with square brackets there. Now, moving on to tuples. So tuples are indicated with a a pair of just normal brackets, and they are a bit more restricted than lists in some ways. So like a list, a tuple is ordered. So when we print this tuple out, we're still going to get apple, banana, cherry at the bottom. There you go. And again, there we go. However, they are not mutable. So say if I want to do what I did with the list before and add the element orange at the end, that's not going to work. We're going to get an error. So when I run that, yeah, we get this tuple object has no attribute insert. We get an attribute error. So tuples, they are not mutable. They're what's called immutable. Now, also with tuples, as you probably may have guessed, you can't change the value of an element in a tuple after it's been initialized. So again, say we tried to do what we did before with lists and change apple to strawberry, we're going to get an error. There we go. Yeah. Tuple object does not support item assignment. That's a type error. That doesn't work. So tuples, you can't change the value of an element in a tuple after it's been initialized. But here's one thing that tuples do allow again, is they are, again, like lists, fine for you to have duplicates. So we'll see banana, banana, cherry at the bottom, no problem. There you go. So tuples, they are ordered, they are immutable, they're not mutable. You can change the value of you can't change the value of an element in a tuple after it's been initialized, but tuples do allow duplicates. Okay, now we're going to move on to sets, and sets are indicated with curly brackets. If we Okay, so if we print this out. Okay, so unlike lists and tuples, sets are not ordered. Okay, so when we print out this set here, there's no guarantee it will say apple, banana, cherry in that order. It might say cherry, banana, apple. It might say banana, apple, cherry. We have no idea. So print this out, banana, apple, cherry. Print it out again, cherry, apple, banana. So sets, they are not ordered. They are mutable, however. So again, if we wanted to add the element or the string orange into the set, we will get it saying apple, banana, cherry, orange at the bottom here, but not necessarily in that order. So yeah, this time it's saying cherry, banana, orange, apple, but orange is in there. So sets, they are mutable. Like tuples and unlike lists, though, they do not allow you to change the value of an element after it's been initialized. So again, say we try and change apple to strawberry, that's just not going to work. We're not going to get strawberry, banana, cherry, or some variation of that down here. We're just going to get an error. There we go. Again, another type error. Set object does not support item assignment. So sets, they do not allow you to change the value of an element after it's been initialized. And finally, duplicates. Now, this is the key feature of sets, is that they do not allow duplicates. But it won't fail with like an error in the same way that we've seen with other properties that get violated in the other collections. So what's going to happen here instead is that all but the first, so we've got banana written twice here, but what's going to happen is that all but the first instance of banana is going to get deleted from the set, and so it will just say banana cherry or cherry banana at the bottom here. And there you go, it just says banana cherry. There's, banana is only shown once. So sets, they are not ordered, they are mutable, they don't allow you to change the value of an element after it's been initialized, and they don't allow duplicates. And finally, dictionaries. Now again, dictionaries, they're indicated with curly brackets like sets, but as I said before, they have these key value pairs rather than just single data type elements. So this dictionary is going to have its keys being apple, banana, and cherry, the values being 0, 1, and 2 respectively. So it's got three key value pairs: apple 0, banana 1, cherry 2. Now, like sets, dictionaries are not ordered. So when we print this out, again, there's no guarantee it'll come out in this order. And it doesn't. So it's showing banana 1, then cherry 2, then apple 0. And we run it again. And that's showing apple 0, cherry 2, banana 1. So dictionaries, they are not ordered. They are mutable, however, but it works, as I said, dictionaries are the odd one out. It works slightly different to the other collections. So what we're going to try and do here is add the key value pair orange 3 to this dictionary. Now, depending on now what the difference here, the sort of the quirk is, it depends on whether the key specified here, the string, already exists in the dictionary. So if it does, then it just means the key value pair with that indicated string, its value is going to be updated by, to whatever's on the right-hand side of the equals sign. If it's not, if this key isn't, this string isn't in the dictionary, however, then we're going to get a new key value pair with, obviously, this is the key and that is the value. Okay, so this is going to show apple 0, cherry 1, sorry, apple 0, banana 1, cherry 2, orange 3 at the bottom here, but again, not necessarily in that order.
Hey, Robert, just a super quick question on the YouTube chat as well. Is there anywhere that you'd recommend kind of trying along? So if people want to code alongside, is there any useful links or anything?
I can put these in the this is quite good. I can put this in the chat
Yeah, that'd be awesome. Then I'll share it.
if you want. Where is it? There's the chat. No, that's the. Oh, is it? Sorry.
No problem. Just want to make sure those who are interested want to.
Check camera settings. No, okay. Sorry. Sorry, I'm having a little bit of difficulty finding the chat function again. Where was it? Share grid.
Always a nightmare to find. In the bottom right, if you're in the window.
Okay, or actually, I can just go to the I can just go to the main WebEx. Bottom right hand. Chat. There we go. There we go. Okay. To everyone. Okay, found it.
Awesome.
There we go.
Right,
Sorry
I'll
about
share
that.
that in the YouTube chat now. Thank you very much, and I'll let you continue.
Okay. Okay. So, yeah. So dictionaries. They are mutable. You can change the structure. You can add new key value pairs. Now, and this sort of covered this in what I said before. Now, when it comes to changing the value of an element that's already been initialized in a dictionary, you can, because you can change the value in the key value pair, but not the key. So what we're going to do here is just update the value associated with the Apple key from 0 to 3. There we go, cherry 2, banana 1, but Apple 3 at the bottom there. And finally, duplicates. Again, dictionaries are kind of like the odd one out when in terms of collections. So strictly speaking, no, you can't have duplicates in a dictionary. You can't have duplicate key value pairs because you can't have duplicate keys in a dictionary because of what I've explained before. But you can have duplicate values that have different keys associated with them. So say I made a new key called strawberry, and I also gave it the value 0. So what we're going to get is apple 0, banana 1, cherry 2, and then strawberry 0. So we're going to have duplicate values, but not duplicate keys in this dictionary. But again, not necessarily in that order. There we go. We've got strawberry 0, and we've also got apple 0. So when it comes to collections, so when it comes to dictionaries anyway, they are not ordered. They are mutable. You can change the value of an element after it's been initialized. But strictly speaking, you can't allow duplicates. However, you can have duplicate values, if not duplicate key, but not duplicate keys. And finally, okay, loops. So in Python, if you have a bit of code and you want it to execute multiple times, you use what's called a loop. And there are two main kinds of loop in Python, for loops and while loops. Now, for loops are for when you know how many times you want the bit of code to repeat. They have a set number of repetitions, or what officially called iterations, and they can loop over any kind of collection. You can just have a counter variable, or you can have a counter variable that just counts up after each iteration. Or, and I think this is quite unusual, it might even be unique to Python, you can also loop over a string with a for loop. Now, on the other hand, you've got while loops. They're the complete opposite. Therefore, when you don't know how many times you want the piece of code to repeat, all you know is you want it to keep going until a condition is violated or met, depending on how you look at it. They also actually, now I mentioned before with for loops, you can have them with a counter variable. With while loops, you need to have this counter variable. If you don't, you'll get a problem called infinite regression, and that can break your code and sometimes even the computer. So the way I like to think about the difference between these two is I use the analogy of the 10,000 meter race at the Olympics. So if you think about the 10,000 meter race, it's not the participants running once around a 10,000 meter track. It's them doing laps of 400 meters, 25 times to be precise. And so if you imagine you're doing that, say you're Mo Farah, for example, and you know how many you're doing the 10,000 meter race, you're executing a for loop in that way because he's running the code run 400 meters. He's executing and looping and iterating over it 25 times. Then on the other hand, let's say Mo Farah is training for the 10,000 meter race, and his coach says, okay, keep running 400 meter laps until you get too tired and can't do any more. Well, in that case, Mo Farah's doing the equivalent of a while loop because he's executing the code run 400 meters repeatedly and iterating over it until he violates the condition of stamina effectively and can't do any more. Again, let's go back to the online compiler and show you that. So we're going to make use a list because, as I say, lists are kind of like the workhorse collection in Python. They're the easiest to use. And again, we're going to have apple, banana, cherry, but we're going to call the list fruits this time. Now, to start the for loop, we use a for keyword. As I said, Python's very easy to use. It's a pretty obvious thing to call it, and you can tell it's a keyword because it's highlighted in orange there. We're then going to write an individual element of the collection we want to loop over, and obviously since this collection is called fruits, we're just call it fruit. Then we use this in keyword, again in orange, and this means in the collection, which is fruits. So as I say, Python is kind of quite intuitive, quite easy to understand. So it's saying for an element fruit in a collection called fruits, we're going to do this. We're going to do this bit of code, and the code in question here that we're going to do is just print each fruit. Now, also note that the for loop statement here, it ends with a colon, and a lot of statements in Python end with colons. So bear that in. Make sure to put your colons there, otherwise you'll get errors. So when we execute this for loop on the first iteration, it's going to go to apple and print out apple. Then on the second iteration, it's going to go to banana, print out banana. Then on the third iteration, it's going to go to cherry and print out cherry. So we should see apple, banana, cherry at the bottom. And we do. It says apple, banana, cherry. So that's a for loop. Now let's do a slightly different thing with a while loop. So like I said before, most important thing with while loops, you need to make sure you've got what's called a counter variable. And this variable I'm going to call I here and set it equal to 0 to start with. Then we start the while loop with the while keyword. And we're going to set a condition here, which will break or stop the while loop, which is so long as the fruit is not equal to cherry. Bear in mind, this is what's called this exclamation mark then equals sign is called the not equal to logical operator in Python. As long as it's not equal to cherry, we're going to print out the fruit. And I'm having to do this indexing here because unlike with for loops, you can't really loop over a collection like that with, or so easily at least with while loops. Now, and this is very important, I'm going to do what's called an iterator statement here, where I'm adding 1 to the value of I here, because if I don't do this, I'll get the infinite regression problem and the code will break. So now what's going to happen here is, so on the first loop, it's going to go to apple, see that apple is not equal to cherry, and print it out. Then on the second loop, it's going to go to banana, also see that that's not equal to cherry, and print it out. Then on the third loop, it'll go to cherry, see that obviously that is equal to cherry, not print it out, and the while it will break, the code will stop. So we'll see apple and banana at the bottom here, but it won't print cherry. Also, while it's doing those loops, obviously this I will increase by 1 after each iteration. There you go, just says apple and banana, but it doesn't say cherry. So that's a while and a for loop in action for you. then we're going to move on to packages. Now, packages are Python's bread and butter, as I said before. These are the things that really make it such a useful language. You'll also sometimes hear them referred to as modules, but you can think of a package like in Python, kind of like an Amazon package in real life. So, it adds functionality or variables or both to a Python function. So, if you imagine your house as a Python function, say, and it's got lots of things you can do in it. You can watch TV, you can cook food, and put out the bins, whatever. But say you want to make smoothies, but you can't do that because you haven't got a blender in your house. So what do? Well, you go to Amazon, you order a blender off of there, it gets delivered to your house, and you import the package when you take it from the delivery person. And then you can consider, your house has more functionality in that case because now you can also carry out the function, run the code of make a smoothie. Now, in terms of how do you actually import a package, actually in Python using Python code. So all you need to do is just write the import keyword and then the name of the package. Something you can also do, and unfortunately, this is where the analogy breaks down a bit because you can't do this with Amazon packages. You can rename the package if you want to a name of your own choosing, say, because you think the standard name is too long. So to do that, you just write the as keyword and then the name you want it to be. So one thing I often do is I import a package called NumPy that's spelled NUMPY, and then I put the as keyword here and I just rename it to NP. Now, how do we actually use a package? So to do that, we put a dot here. This is called dot notation, and then we write the name of the package method or its a field or attribute variable we want to get hold of. And depending on whether it's a method or attribute, we'll need to also put some just normal brackets there. And this is really, again, just what makes it so great to work with Python is you can just import a package, you can call on any methods or attributes or both that you need from it, and it enables you to just build your function or functions so much more quickly. Now, there are two types of packages in Python. There are the built-in packages, things like math, which is just a package that does more complicated math operations than just very, very basic Python. So you can do things in math like finding the greatest common denominator, square rooting, and modular division. There's unit test, which is the basic testing package in Python. And finally, there's sys, which allows you to kind of meddle with a computer system. And that's just a few of them. As I said before, there's over 300 of these built-in packages in Python. Now, unfortunately, there's also packages that are not built in with Python. And for those, you need to do something called pip install. We might, talk about that later, but pip install is just something you have to run to install the package on your computer before you can successfully import it. And there's 10 times as many of those not built-in packages. So yeah, that's something to bear in mind. And the way to tell whether something's a built-in package or not is simply to put the import statement in your code, run the code, and then if you get an error saying package name not recognized, you know it's not a built-in package, and you're going to need to run this pip install command. And finally, when it comes to defining and running functions in Python, that's reasonably straightforward. So what you need to do is you write the def keyword. You then write the name of your function, and it's best practice in Python to write it in what's called snake case, which is where all the words are all lowercase letters, and then they're separated by underscores. You then write a pair of just normal brackets and fill that in with the names of arguments if you need any for your or inputs if you need any for your function. And finally, like with for loops and while loops, you finish off with a colon at the end. Now, another best practice in Python, and this is not optional, you don't have to do it, but I would strongly suggest it, is something called assigning input and output types. And the reason I'd strongly suggest it, or at least to do it as best you can, is because often you'll get errors later on in the code because of variables of the wrong type. This can have huge problems later on in the code, and so having this type checking, which makes sure an input or an output is the right type, and forewarns you if it isn't, can avoid a huge number of catastrophes and problems later on the code. So it's worth doing as best you can, even though it takes a little bit more time. So to do that, what you do is for the inputs, you just put a colon next to them, and then you write the data type. This could be, like the ones we looked at before, string, or str or int complex. Could be a completely different one in Python. It could even be one you've created yourself. But yeah, that can, you just need to say what it is. Then for the output types, what you do is you create an arrow after the closing bracket using a dash and a greater than symbol, and then you write the output type. And again, that's just any data type you want it to be. Just just make sure to specify it. Then when it comes to, now you actually defined a function, but how do you actually use it and call it? Well, to do that, you just write out the function name. You then put, again, a pair of just normal brackets, and then you write the values of, if it's got any inputs, and if you want to use key arguments, you can also put the names of arguments, so it has default values, basically. Then also you have Python scripts and files which might have multiple functions in them. And to run those scripts or files, what you need to do is you write the Python keyword in a terminal, in a command line. You then write the name of the Python file or script, and then, and this is very important, you add this .py extension at the end of the file name. So .py is what's used to indicate that a file or a script is a Python one, is written in Python. So it's really important that you don't forget this extension, otherwise this command won't work. Now we're going to bring all these concepts together in a sort of big Python function I've created. To give you a little bit of background on this function, so if you imagine you're a greengrocer and you've got a bunch of individual fruits and you know their individual weights, but you want to stack them in 1 kilogram boxes, and you want to make sure these only one type of fruit is stacked in a box, then this is what this function will do. So you might, for example, not want to stack apples and bananas together, because that means the apples will ripen too quickly. So what this function is going to do, it's going to take in a list of individual fruits that are just going to be numbered with, and have dashes on them, and their individual weights. And then it's going to produce another, it's going to output another dictionary with each type of fruit, whether it's apples, bananas, cherries, whatever, and it's going to tell you how many 1 kilogram boxes you need to stack up the total weight of that fruit in each value. So again, going back to the compiler, so this is the function I've created here. Like I mentioned in the function definition, I've started this function, which is called calculate boxes in snake case there, with this def keyword. We've then got the normal brackets, and in them we've got this input called fruits individual, which again is just individual fruits and their individual weights. And I've, as with best practice, I've assigned it the type of dictionary. Then after the closing bracket, again, I've assigned the output type to also be a dictionary, using that, the dict type and the arrow there. And of course, this function definition ends with a colon. I've also imported this math package here that I've renamed it to maths. Now this is because there's two important functions that we're going to need to use in this maths package later on for calculate boxes. Now, okay, so what is this code on the whole doing? So firstly, what it does is it just takes the input and it looks for what the names of all the names and numberings of all the individual fruits are, and it does it with this keys method here. Then what it does is it'll create this new empty dictionary called fruits total, and for each individual fruit, it will use this .strip function to get rid of the numbering, and it can do that because obviously these fruit names are keys, so they'll all be strings. And then it will put that it'll put the type of that fruit is, so say it's apple 1 and it's stripped off the numbering, so it's just apple. It'll put that as a key in this new fruits total dictionary, and it'll add the weight of that individual, say apple in this case, to the total weight of apples. Now, this is where the first function from the math package comes. So this function here is called fsum. It's a shortening of floating sum, and basically what it does is it'll it adds together floats or decimal numbers without losing any decimal places or accuracy. And as you can see, since we're working with kilograms here, and you take a fruit like cherry, which is going to be only a few grams, it's going to clearly be a decimal, a float. When you're working with kilograms, we need to make sure that we're using this fsum function so we don't get inaccurate outputs later on. Then what we're going to do is we're going to use a while loop this time, and we're going to create another empty dictionary called fruit total boxes. This fruit total boxes will be our final output, and it's going to go over the fruits. This while loop is going to go over the fruits total dictionary, and it's just going to look at the values in each one, the total weight of fruit, and then it's going to round it up using this for each total weight of fruit. It's going to round it up using this ceil function. Now, ceil is just a shortening of ceiling. It just means that it takes any input and rounds, or any number input, and just rounds that up to the nearest integer. Obviously, as it's a while loop, I've also got this counter variable here, which I've initialized at 0, and then I'm making it iterate and add 1 to it each time after every iteration to make sure we don't get that infinite regression problem. Then I'm going to print out this fruit total boxes at the bottom here, so you can see the result. And I'm using this return word here. This will make sure that this output assignment I've done of dictionary here makes sense basically, and will ensure that that doesn't break or start throwing errors. And finally, and this is kind of the most important line really, is the call to calculate boxes to actually run and do something with an input. So the input here is this dictionary Apple1. So it has first two keys are Apple1 and Apple2. Obviously, they're both apples, so their weight will be added together to be 1.215. And obviously, that's not a whole number. You can't have 1.2 of a box, so that's going to be rounded up to 2. So the first key in the output box is, or one of the keys will be Apple, and it'll have the value 2 associated with it. Then you've got cherries, and now there's only one cherry, so there's no adding going to be done. But obviously 0.03 is a float. You can't have 0.003 of a box, so that's going to be rounded up to 1. And similarly with a banana, there's just one banana, so that's going to be rounded up to 1 as well in the output. Though obviously the banana box will be a bit more full than the cherry box. So right, if we run it. So yeah, you see at the bottom we've got this output dictionary. Banana has 1 kilogram box associated with it. Apple has 2 because there's 1.2 kilograms of apple. And finally, there's only 0.0003 kilograms of cherry, but it'll have one very empty 1 kilogram box associated with it. So thank you for listening, everyone. That's my function. That's my presentation. Any questions?
Thank you very much for that, Robert. I have certainly learned something about Python that I did not think was possible considering my limited tech skills. But no, that was great. And I think you kind of hit the nail on the head with, from a novice's perspective, the intimidating look of some languages versus this. Yeah, it's much easier. Just give everyone a second to see if they've got any questions on the chat. But I think just a big thank you to you, Robert, for giving up your time. I know you spent a lot of time preparing it, getting it all sorted. And yeah, I hope everyone else found it as interesting as I did. If you don't think of any questions for now, let me know. We're always on Discord. We can always ask then. But I think it's looking relatively quiet on the chat. So unless you have anything else to add, Robert, I think that would be good place to end.
No, yeah, no. So I just want to say thank you for giving me the opportunity to come on here. It was great, and I'm happy people have all learned something new about Python.
Awesome. Well, thank you very much, and hopefully we'll see everyone later. Bye.
Right.
Cool.